Okay, so first we're going to work with the front page, which is the linear quadratic, the linear characteristics of functions. And this is, all you're doing is you're just writing whatever I write. So if I write, you write. So over here, they're asking us for the linear parent function, and we learned this on Friday. What is the equation of a linear parent function? Y equals x. So we just write y equals x. Okay? And then the domain and the range is something that we haven't talked about yet. We're going to talk about it this week. But the domain is all real numbers for the y equals x, for the linear parent function. So you would put all real numbers. Okay? And the range is also all real numbers. When you put that equation in decimals, it's going to give you a graph and it's going to give you a table. So right here, I would put y equals x. And this is the graph that it gave me. And this is the table that it gives me. So those are the points. So we're going to go ahead and graph those points, and we're going to put this on the table. So if you need to, you can pause and do it. Okay, so on the table, we're going to put negative 2 gives me negative 2, negative 1 gives me negative 1, 0 gives me 0, 1 gives me 1, 2 gives me 2, and if I was to pick any other number, 3 gives me 3. So when you plot those points, on here, it looks like this. And then you connect the dots. That is the linear parent function. Okay? Okay, so let's go to the next line. Right here, when it's asking for the forms of linear equations, these are all in your formula chart. And I haven't given you a formula chart yet, but when you see it, this is what it looks like. Okay? And this is where you would be looking for linear equations. This is the standard form. Write it down. This is the slope-intercept form. Write it down. And this is the point-slope form. Write it down. You can pause the video at this time so that you have time to write them in. So hopefully this is what you wrote. AX plus BY equals C. The point-slope form was y minus y1 equals m times x minus x1. And the slope-intercept form is y equals mx plus b. And you've been using that one since last year. Okay, if you have any questions, make sure you raise your hand during the video. Another cool characteristic that linear functions have are the slopes. The slope of the linear function. And how would you define a slope? A slope is how the line rises or falls. Okay? How the line rises, how it goes up, or how it falls, how it's coming down. So right here it's asking can you explain how to find slope from each representation? So you've done this before already, so we're gonna get back into slope pretty soon, but I'm just gonna hit it just how you would do it the easiest way and the fastest way. So for this one, it's a graph, so you would count the rise over the run. Okay, the rise over the run. So from left to right, how much do you rise and how much do you run? So you would just count up 1, 2, 3, 4, and over 1, 2. So my rise is 4, my run is 2. And when you divide that, it gives you a slope of 2. From a table, I would just do the change of y, how much my y's are changing by, divided by the change of x, how much my x's are changing by. So from 5 to 19, how much did that change? It increases plus 14. From 5 to 19, it was plus 14. So a positive 14 goes on top. And how much did my x's change by? By 2. By a positive 2. They increase by 2, so that number goes at the bottom. Okay? And then you just divide it. 14 divided by 2 is 7. The slope of that table is 7. Same thing here. How much the y's are changing by, or you can use the formula y2 minus y1 over x2 minus x1, the slope formula. So that's negative 5 minus 3 divided by 4 minus a negative 1. Change this to a plus, right? So then you have negative 5 minus 3 is a negative 8. And 4 plus 4 is positive 8. Divide it, and that gives you a negative 1. Oh, this is a 1. See, that was a 4 minus negative 1, so it's plus a positive 1. So that's still negative 8 on top, and on bottom that gives you 5. So that's the slope of that, those 2 points. And then on this last one, all you have to do is look for the coefficient of x. The coefficient of x. So the number in front of the x, but you have to make sure that it's solved for y. So make sure that it is solved for y. Like letter A, is that one already solved for y? Is it in y equals? Yes, it's already in y equals, so the coefficient of x would be negative 2, so that would be the slope. Is B already solved for y? Yes, so the coefficient of the x would be the slope. Is C solved for y? No, you would have to move the 3x over, change the sign to a minus 3x, and then that's the slope. The negative 3 would be the slope of that line, because that would be y equals 8 minus 3x, and that's how it's already solved for y. Okay, if you need to pause the video and finish this up, go ahead and finish it up so we can go to the back page. Okay, so let's go to the back page. Now we're going to do characteristics of quadratic functions. And in this one, they gave us a word bank. So we're going to use those words to fill in 1 through 8. Okay? So for number 1, standard form of a quadratic function is ax squared plus by plus bx plus c. And that can also be found in the, right here where it says quadratic equations, standard form. So if you ever forget it, that's where it is. Okay, so let's go back and put it on our sheet. So we're going to write down that it's y equals ax squared plus bx plus c, and you cross it out because we're not going to use it again. Number 2, the shape of the quadratic equation. So what is it? What does it look like? This is what it looks like. And what is that called? Does anybody know? It's called a parabola. Okay, this thing right here, this shape, is called a parabola. Not parabola, parabola. Number 3. This red line, what do you think it's called? Look at the stuff that we have left. That red line that cuts it down the middle and makes it the same on both sides. It's called the axis of symmetry because then it makes it symmetrical. The parabola is symmetrical, so it's called axis of symmetry. Okay, and then this point down here at the bottom. This point right here. That's in the middle of the parabola is called the vertex. The vertex. So when this vertex, this point, when the vertex is the highest point, what do you think is going to be, minimum or maximum? It's going to be a maximum point. When it's the highest, el punto más alto, the highest point is a maximum. What do you think it's called when the vertex is the lowest point, like right here? It's called a minimum. When it's at the very bottom, el punto más bajo, that's the minimum. Okay? Our solutions. The solutions are called the, let me cross this out, the x-intercepts. Okay? And solutions to quadratic equations are also called zeros or roots. So if I go too fast, make sure that you pause or rewind so that you can get everything written down. Okay, at the very bottom, we're just going to talk about how many solutions or roots there are. So for instance, number 9, this is the y-axis, this is the x-axis. Roots touch on the x-axis. Okay, there are the x-intercepts. So how many roots do I have here? 1. I only have 1 because there's 1 x-intercept. Okay? The zeros, that's the same thing as roots. So what is this number here? Here's 0, 1, 2, 3. So my 0 or my root is at 3. Okay? Number 10. Again, this is my y-axis, this is my x-axis. Where does it cross the x-axis? What is the x-intercept? Is there one? No, because look at where it's at, it's down here. So that's not an x-intercept. So we're going to say that we have none. How many roots? 0. How many zeros? None. No hay. Number 11, what are the number of roots? How many times or how many x-intercepts do I have? 2. I have 2 x-intercepts. And where are they at? What number is this one? This is 0 and